Hi, everybody. My name is Wang Yang. So I'm happy to share an optical phenomena which is called refraction. And if you can see, the world is composed by different color. This is the diffraction phenomena, and I will show in the following slide. So there are a couple of pictures of light. The first one is ray picture. If you can see the object through by a peephole, then the image is reversed on the image plane. But if the hole is more bigger, then you can see your image is more blurred. So this is a ray picture. And another picture is the wave picture. There are a couple of phenomena which is called diffraction, interference, polarization. Based on the wave picture, can explain this natural phenomena. And the third one is the particle picture, which is discovered by another modern scientist like the Planck, Einstein, use this picture to explain some modern like a photon, and use the photon to explain the photon electron effect. But today we will focus on the ray picture, which has the two famous phenomena, which is called refraction and reflection. So for refraction, it is very easy. When you shine a light to a mirror, then you can see the refraction angle. You can see the incident angle and reflection angle is the same. But for the refraction, let's go to the first experiment. So while the arrow behind the cup is the right hand side, but you pour the water to the cup, then it will become to the left hand side. So the answer is that if there's no water in the cup, then you can see the light goes through like a straight line and on the image plane. But if there's water in the cup will, just like a spherical glass, then the light will bend through the glass and to the image plane. So you can see the image is reversed by from the object. And it is the same phenomena like you use the lens to clear the image into the peephole. So you can get a clear image like using a camera. And the principle of the refraction is like that. When you shine a light from the sparse medium to a dense medium, or vice versa, the light will be bent. The basic principle is when the light goes through different material, the light will go through with a different speed. And if you think about a column of the march troop walking on the concrete, from the concrete to a swamp, then from the left soldier, he will get the less dense material like the swamp first. So he will decrease his velocity. But for the left soldier, he was still in his velocity. That's why the light will bend. And if you can see more clear in this picture, the left soldier go through a different speed first, but the right soldier will go the same speed until he gets the less dense material. And if you can see the picture with the continuous diagram, then you can see the light goes through like this way. like I showed in the first slide, actually when you shine a white light in the different material, the different color will be expanded. So you can see red, green, red, orange, yellow, green to blue, purple. The light will spread out. So let's go to the experiment 2. If you put a pencil into the like a water or something else, you can see the pencil is like a bend. So why this phenomena? It is like that. Actually, when we see the pencil, we will suppose the light is straight. So this is called sight. But actually, light is reflected by the water. So the actual light is go through this line and to our eyes. So this is another important phenomena which is called the principle of the reversibility of the light. In the previous slide, I used the light go through the sparse material to the dense material. But how about the vice versa? So if you can see, if the light is under the water, then if the instant angle is 0 degree, it still go through the air. But if I increase the instant angle from the 20, 30, 40 to 60 degree, because of the light is bending more in the dense material, in the less dense material, so the refraction angle will increase much more the instant angle until it goes to the 90 degree. And if the refraction angle is larger than 90 degree, then the light will total reflection. So this is another very important phenomenon which is called total internal reflection. And there are a couple of conditions it will satisfy in this total internal reflection. The first is the critical angle is the first one is critical angle. So it means the instant angle when the reflect angle is exactly 90 degree. And the first one is only occur when the angle of the instant increase past the critical angle. Second one is can only occur when the light travel from a more dense material to a less dense material. Vice versa, you cannot see this phenomena. And third one is it's no longer any reflection and just reflection. So scientists use a different number to describe different material. This is we call index of refraction. We define the vacuum is equal to 1 and another air which has some hydrogen or nitrogen. So the index of refraction is a little larger than vacuum. And the water is composed by H2O and the ice and diamond. So more dense of material has more large index of refraction. So that will induce another very important law which is called Snell's law. And I think in your math class you have learned about this math. So the math is described by n1 times the sine theta 1 is equal to n2 times sine theta 2. So for practice, you can calculate if the sunlight go through from air to the water, then if I give you the index of refraction which is 1 and water is 1.33, in the instant angle is 30 degree, then what is the refraction angle? I will give you a couple of minutes to calculate, maybe 1 minute. Or you can stop the video. So this is the answer. We use the formula like this, which is called Snell's law, and put all of the number into this equation. then you can calculate the theta 2 is about 22.09 degree. In vice versa, when we shine a light from a more dense material to a less dense material, based on the critical angle, which is 90 degree, so 90 degree, we know the sine 90 degree is 1, then we can use this formula to calculate which is the critical angle. So another practice is like that. When we shine a light from water to air, so what is the critical angle in this condition? And again, I will stop 1 or 2 minutes to let you calculate. Okay, so the answer is 48 degree. And the most important for the total internal reflection is fiber. If you can see, there are a couple of the glass on the table. So if I use my laser pen go through the glass, you can see the light will come from this way. But if I increase the instant angle like that, then you can see the light is go through a couple of times to reflection from the air to the glass. I don't know you can see because yeah. And if you want to see the more clear demo, you can watch these 2 videos. They do the same thing as me. And if you see another experiment like the round groove glass, then it is also show the total reflection from this point to this point to this point. Because the glass has a curvature surface, so it is not like the rectangle glass. So the light will bend through the glass in a different direction. So this is the very important experiment and application in our internet right now, because we can use the light to transfer the information or the video or the audio. So this is the global undersea fiber network. You can see the origin light is the fiber, which is like that. Well, each of the orange line is like this one line. So when you shine the like a flashlight into the fiber, you can see all of the light will go through the fiber, and you can receive the signal from each of the channel. So that's why the fiber is work in the undersea. And actually, in the American, you can see a lot of knot in different cities, because the light will go down the intensity into different couple of kilometers. So we need to use some amplifier to increase the signal. And why we use the fiber is important, because if you use the electrode to transfer the information, then it will lose by the copper line. So the light will go, if we use the light, then the signal can transfer very long distance. So that's why we use the fiber in the modern information transfer. So thank you, everybody. This is my presentation.